Here we are going to solve for the linear transformation of vectors 2, 1, 0 and 2, negative 1, 2 without any given definition of what's the transformation, but we have this three different given here. Notice that in our previous videos, just before this one, you might want to check that out. The vectors used there was 1, 0, 0, 0, 1, 0, and 0, 0, 1. That's why it's very easy for us to come up or construct with correct coefficients. But here we have 1, 1, 1, 0, negative 1, 2, and 1, 0, 1. And then it might take a lot of time here. So please bear with me here. We're going to discuss the entire process here because we have two unknowns here. What we could do in solving for the first 2, 1, 0, okay, is to come up with a linear combination of this together with the given vectors now. Okay, but when writing that, we have A 1, 1, 1 plus B 0, negative 1, 2 plus C 1, 0, 1, where A, B, and C are element of real numbers. Before we could come up with the result or the answer to this, let's still start rather by solving for these coefficients here. And this is the process which may take a lot of steps. But anyway, let's do it like this, and we're going to do it step by step. You have 2, 1, and 0. Here you have A. This is 0, negative B, 2B. You have C, 0, and C. Then you will have here 2, 1, 0. That's A plus 0 plus C. A minus B plus 0. And A plus 2B plus C. After this, we can say that according to the corresponding entries, A plus C equals 2. A minus B equals 1. And A plus 2B plus C is equal to 0. Here, of course, we can not automatically guess what are the values for A, B, and C, unlike again the previous video. But what we can do here is to solve for the values first. Why do we need to solve for A, B, and C coefficients? Because once we are done with the value, we can now operate the linear transformation of this. So what we could do here is this one here. Let's come up with an augmented matrix of this. We have A, 0B, 1C, and then you have your 2. A, negative B, 0C, and 1. You'll also have here A plus 2B plus C equals 0. So we're going to make a row echelon form of this. You can even use reduced row echelon form, but in this case, to shorten the video, I'm just going to use here the row echelon form. So what we could do here is to simply multiply negative 1 to R1 and plus it to add it to row 2 for a new row 2. The same thing, R1 plus R3 to R3 to make this 0. Of course, you need to review how do you make row echelon forms of this. So I hope that these spaces are enough here. So you have 1, 0, 1, 2. So we have negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times 0 plus negative 1, negative 1. Negative 1 times 1 is negative 1 plus 0 is negative 1. Negative 1 times 2 is negative 2 plus 1 also negative 1. Next, negative 1 times 1 is negative 1 plus 1, 0. This is still 2. This is 0. Negative 1 times 2 is negative 2. Okay? Next is to make this positive 1. So we're going to multiply negative 1 to row 2 for a new row 2. So I'm going to use horizontal motion so that I have spaces here for the second because we have to solve 2. So this is 1, 0, 1, 2, 0. Now this becomes positive, big positive, positive, 0, 2, 0, and negative 2. To make this 0, we're going to multiply negative 2 to row 2 plus row 3 for a new row 3. This would mean 1, 0, 1, 2, 0, 1, 1, 1. We have here 0. Negative 2 times 1 is negative 2 plus 2, 0. Negative 2 times 1 is negative 2 plus 0 is negative 2. Negative 2 times 1 is negative 2 plus negative 2 is negative 4. And finally, we're going to divide or multiply negative 1 half to row 3 for a new row 3. This will be your final form of the matrix here. Okay? It will become 1, 0, 1, 2, 0, 1, 1, 1, 0, 0, that's positive 1, and negative 1 half times 4, negative 4 is positive 2. This would mean this here, C is 2. Okay, that's the C. Using this equation, B plus C equals 1. So you'll have B plus 2 equals 1. B is negative 1. And then for our first equation rather, you have here A plus C equals 2. A plus 2 equals 2, so A is 0. These are your three coefficients needed for this here. Okay? So what happens now is you're going to use that here. Let's go back. I don't know if this space here is enough. But let me rewrite this one here. 2, 1, 0. So you have 2, 1, 0 is A. So 0 of the first, 1, 1, 1. 1, 1, 1. Plus B, which is negative 1 of the second here, this one here. 0, 0, negative 1, and 2. 0, negative 1, and 2. And plus C, which is 2 for 1, 0, 1. Okay. Of course, you can always check whether these coefficients are correct. But the point here is this. Okay, the point here is this. Once you take the linear transformation of this, you're also going to take the linear transformation of this entire expression on your right hand side. Negative 1, 0. So that's negative 1, 2 plus 2, 1, 0, 1. Okay. When you have the linear transformation of a sum, you can just simply make it as the sum of separate linear transformation. That's one of the theorems that we have learned here. Plus here, negative 1. We have 0, negative 1, and 2. Plus, we have here t of 2, 1, 0, and 1. Then you have the constants. Constant. You can take it out. 0 times the linear transformation of 1, 1, 1. Okay. Plus negative 1 times the linear transformation of 0, negative 1, and 2. Plus 2 times linear transformation of 1, 0, and 1. And what are the results here? That's 0 times the linear transformation of 1, 1, 1 is 2, 0, negative 1. Okay. 2, 0, negative 1. Plus negative 1 times the linear transformation of 0, negative 1, and 2. 0, negative 1, and 2 is negative 3, 2, and negative 1. Again, negative 3, 2, and negative 1. Plus 2 times linear transformation of t 1, 0, 1 is 1, 1, 0. 1, 1, 0. Okay? That would mean you have 2, 1, 0 here. These are all 0. This would become plus positive 3, negative 2, positive 1, plus 2, 2, 0. Which will give us the final result just for this alone. Just for this item here. 0 plus 3 plus 2, that's 5. 0 minus 2 and then 2, that's 0. 0, 1, 0 is 1. So this is the result for the linear transformation of the vector in R3 2, 1, 0 being 5, 0, and 1. Let me see if I still have spaces. I don't have much space. But anyway, let's try to solve 2, negative 1, and 2 with this enough spaces here. So we have 2, that's negative 1 and 2. Okay? Negative 1 and 2. So pardon me with the space. I hope that this is enough. So what you could do is again come up with the linear transformation of this. You have A times 1, 1, 1. Okay? just here, plus b 0, negative 1, 2, plus c 1, 0, 1. 2, negative 1, and 2 is equal to a plus 0, negative b, and 2b, plus c 0, c. So 2, negative 1, 2 is equal to a plus c, a minus b the same, a plus 2b plus c as earlier. Okay, so let me use this portion here for the matrix form. Of course, you have a plus c is 2, a minus b is negative 1, a plus 2b plus c is 2. So you will have 1, 0, 1, 2, 1, negative 1, 0, negative 1, 1, 2, 1, and then 2 here. Okay. First is again, come up with 0 here. So negative R1 plus R2 for a new R2. Negative R1 plus R3 for a new R3. So we'll have this space here. 1, 0, 1, 2. So that's 0, right? Negative 1 times 0 plus here, negative 1. Negative 1 times 1 is negative 1 plus 0, negative 1. Negative 2. Negative 1 times 2 is negative 2 plus here, negative 3. Next, negative 1 and then 0. Negative 0, so we have 2. Negative 1, so 0. Negative 1 times 1 is, negative 1 times 2 rather, is negative 2 plus 2, 0. Next, multiply negative 1 to R2. That's R2. For a new R2. So 1, 0, 1, 2. These are all positive now. 3. 0, 2, 0, 0. Finally, make this 0 by multiplying negative 2 to row 2 plus row 3 for a new row 3. They will have it here. So 1, 0, 1, 2. Okay. Then you will have 0, 1, 1, 3. Then 0. That's 0. Negative 2 times 1 is negative 2. Then you have negative 2 times 3 is negative 6. Then negative 1 half for row 3. For a new row 3. So you'll have this final row echelon form. 1, 0, 1, 2. 0, 1, 1, 3. 0, 0, 1. Negative 6 times negative 1 half is 3. This would mean your C is 3. Using this, B plus C is 3. So B is 0. And using this first equation, you have A plus C is equal to 2. A plus 3 is equal to 2. A is negative. Sorry. Move it here. A is negative 1. So you have negative 1, 0, and 3. That is the last, the final step you could place here. So you will have 2, negative 1, and 2. I don't have much space. Negative 1 times 1, 1, 1 plus 0, 0, negative 1, and 2. And your C is a 3, 1, 0, and 1. Make this transformation. So you have transformation negative 1 times 1, 1, 1 plus 0, 0, negative 1, 2 plus 3, 1, 0, 1. Then, so we can now apply the two methods at once, separate them. So yeah, let's separate them first. So you have 1, 1, 1 plus another here 0, 0, negative 1, 2 plus t of 3, 1, 0, 1. 2, negative 1, 2. Negative 1 times t. Okay. T of 1, 1, 1. Plus 0 times t of 0, negative 1, and 2. Plus 3 times t of t of 1, 0, 1. We have it this here. These values are just the same. Okay? So we'll have it here. 2, negative 1, 2. Negative 1 times the transformation of 1, 1, 1. We have it here. So 2, 0, negative 1. Plus 0 times, we have this, negative 3, 2, negative 1. Plus 3 times 1, 1, 0. So you could have, okay, 2, negative 1, 2. So this is negative 2, 0, and then positive 3. So I'm just automatically going to answer 1. Next, 0, 0, 3. And then for the last, you have positive 1, 0, 0. This is the linear transformation for 2, 1, negative 1, and 2 using the values here. Okay? So pardon if I don't have much space, but anyway, at least you were able to see the process. So again, this is how we do it for R3 to R3. So this is all about the solving of linear transformation from R3 to R3. Thank you very much for watching.